Starting. Hello, is anyone there? Anyone hear me, see me? This is always sort of exciting. I'm not sure. Am I talking to me or to myself? Let's see. How do we set there? Volume control. I want that. 0 viewers. Anyone there? All right, so far 0 viewers. I'll give it a few minutes until everyone sort of shows up. Let's see. Oh, well, 3 viewers. There we go. Hello, hello world. Oh wow, more people are showing up. 3 viewers. Well, we had excellent. Oh, okay. So group chat here. I'm going to put in the group chat. We're going to use chat roll for chatting. The URL is yes. I get to talk to myself because otherwise it's very quiet doing a webinar. URL is. There we go. Yeah, last time I tried to do this, I actually used my preferred keyboard, which is super ridiculously noisy. I'll just give you a sample. Right, that's like the quiet mode, and someone begged me to stop doing that next to my microphone, so I acquiesced. All right, we'll give it a few more minutes till everyone shows up. I'm not exactly sure who else is coming or how many. We had about 20 some odd, 25 registered on Eventbrite, and then in setting up the Hangout, I broadcasted to everyone in my Google Plus group. So many of my clients were invited to this too. If any of you are here, don't worry, I'm working on your things. Anyway, we'll get 6 people down here. So anyway, we'll give it a few more moments until people show up, or everyone shows up. Where's everyone from? I feel like a comedian. So where's everyone from tonight? Oh, I think there's a delay in Hangouts of like 10 or 15 seconds. That's going to be fun. Okay. Or no one wants to say where they're from. So there you go. All right, well, we've got 5 people on now. Give it another minute or two, and then we're just going to start. And we'll see who's available and so forth. All right. Let's see. So you see me there. All right. Oh, good. 2 people. Yeah. Oh, somewhere. Oh, Moshe's from Jerusalem. I think if I yell loud enough, you can probably hear me. I'm in Modi'in. Suburbia. All right. We'll tell you what. Why don't we start, and we'll sort of see where it goes from there. So, Sri Lanka, cool. Places always seem exotic if you don't live there. I remember I got to college and I met this woman who was from Iowa, and Iowa has this reputation for being like a super boring, non-exceptional place in America. I don't think she had ever encountered someone who said, "Oh wow, Iowa, that's really cool." So I made her day, or scared her off. Okay, anyway, I'm going to fire this up. So wait, let's see. Getting all these controls and all these windows to work on my computer. Let's see. So I want to share my screen, which is this. And I want to share screen 1, which is that. Let's see if this works. So hopefully you will now see present to everyone. Yes. Bangalore. Oh, wow. I'm glad to know I'm not the only one who stays up late. Yeah, I did this at an hour, so I thought that hopefully people in oh, there's definitely a delay in seeing the chat. Yeah. I sort of did this at an hour when I hoped that people in Europe and the US would also be able to participate. But well, there's someone from London. That's good. London's not exotic. But it seems that people in the US are ignoring us. Ha! Ha! That's what I say. Okay, yeah, and I remember actually, I mean, some of you might know that I do this podcast, The Freelancers Show, with Chuck Wood and a few others, and Curtis and Eric as well. And we did something on Google Hangouts with Chatroll about a week or two ago. And that's when we discovered, or that's when I discovered at least, that there's this 10-second, 15-second delay. I'm not really sure whether it's a technical thing or whether it's sort of like how broadcasters in America, at least, have this 7-second delay so they can shut things off if they're deemed to be offensive and thus save themselves from lawsuits. Okay, so welcome everyone to our webinar in functional programming Python. I did a similar version of this webinar about a month ago, 6 weeks ago, and I had a tremendous amount of fun doing it and meeting people from all over and answering questions. And so we're going to do it again. Obviously, there are going to be some changes here and there, and hopefully your questions and comments will be different, maybe even better than the last group. And I'll probably be doing one of these a month on some technology or another. And hopefully over time, I'll get to know some of you better and better. And you know, anyone who knows me knows I enjoy teaching, I enjoy speaking. I discovered that basically if you do webinars, you get to run your own conference. You don't have to present, like you don't have to be accepted. So for those of you who don't know who I am, so I've been a programmer for a long time, increasingly long time, I discover. I guess every year, longer by a year, right? So I'm a consultant, I'm a developer, I'm a trainer. I probably spend about a third of my time developing software, a third of my time consulting to companies all around the world. I mean, I live in Israel, but in Europe, in the US, consulting with them, leading their development teams, helping their development teams to get better, using typically open source dynamic languages and technologies for the web. And I like to say about a third of my time, but it's probably about half my time nowadays doing training, teaching courses in typically Python, also Ruby, also Postgres, and Git. Those are the main things that I tend to teach, mostly in Israel because I live here. But I've also done certainly training in the US and in Europe, and increasingly in China, which is super, super fun for me. I've been writing a column in Linux Journal for a long time now, since 1996, believe it or not. And as of this morning, very early this morning, I guess it would be like, I don't know, 20 hours ago or something, even less, 18 hours ago, my ebook, Practice Makes Python, is now available. So I'll tell you more about that a little later, but I'm super, super excited about that book. It's still in pre-release. There's still things that need to be fixed and improved, and even a few exercises that I need to finish writing up, but super excited. And anyone with a PhD will show that off to demonstrate that they have survived. So I'll tell you that I've got one. And I got lots more information about myself at my own website. So I want to sort of start with a perspective thing. And the perspective I like to take from a TV show back in, I guess it was the 1950s, maybe the 1960s. So even before I was born and around, that was called The Twilight Zone. And some of you might have heard of The Twilight Zone, or you know, heard at least the music, da 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 da, for scary things. And the idea was that each episode was sort of a science fiction, fantasy kind of story, except that it generally involved paranoia, bad things, but you know, paranoia that was justified because bad things were happening. And so one of the episodes was called To Serve Man. And you see this nice alien here comes down from space along with a whole bunch of other aliens. And they say, we are here to help you humans. And they provide healthcare, and they provide technology, and they provide all the solutions to all the problems we ever wanted. And some people are skeptical, but it just looks, it's so good. They're giving us everything. And they invite a bunch of humans to come back with them to their planet. And this whole time they've been saying, we are doing this because our most important book is called To Serve Man. We are here to serve man. That's why we are being so nice to you. And they are taking a bunch of humans into their spaceship, and they are about to take off, or they're taking off. And one of the scientists finally realizes, aha, I've cracked the code, and runs up to the spaceship, but it's too late. And I believe it's a she. She says, I figured it out. To serve man, it doesn't mean they're here to help us and to serve us. To serve man, it's a cookbook. They're here to cook us and eat us, and that's why they're taking us to their planet. And that's where it ends. And I often think of this when I think of programming languages, because there are just so many programming languages out there, such as, for instance, C and C++, but other low-level static languages that basically, yes, we can do lots of things with them, but I feel like sometimes who's really serving whom here, right? Like, are the language there to serve man in the sense of they're going to do what we want, or the languages exist so that we will have to bend over backwards and do all sorts of somersaults in the air to do what they want? You know, if you're writing code in C or in C++ or even in Java, C#, right, you're always thinking, well, what will the compiler say? What will the compiler do? And the whole idea of high-level languages is that the language is there to serve us. The language is there for us to be able to solve problems easily. Now, one of the reasons I believe for the rise of dynamic languages over the last decade or so is that computers have gotten much, much faster. And software has become more and more complex. And what I sometimes like to say is that in the 1960s and 70s, the most important thing with software was that it worked. If you get your program working, you win. Who cares how ugly it is? Who cares how maintainable it is? Who cares how fast it is? The mere fact that you got it to work, good for you. And then in, like, you know, the 1980s and 1990s, well, that wasn't good enough. It also needed to be fast. And so, okay, you got your program to work, you got your program to work fast, great. But now we're in a new era where programs generally run pretty fast. I mean, especially those of us who do web development or system administration, it's rare for us to have things that are just churning and churning and churning for days. Most of the time things run, they run for maybe a few hours, and then they spit out a result. And we don't care particularly. I mean, I'm not going to say I don't care about optimization at all, but it's much more important, it's much less important that the program be optimized, and much more important that the programmer be optimized. And that's where Python and other high-level languages come in, where they allow us to do all sorts of stuff really easily and quickly, so that, yes, our code is more maintainable. That's really, really important. But the maintenance is just sort of one part of a bigger puzzle. And the bigger puzzle is, how can we make sure that our programmers are working as efficiently as possible? You know, who is serving whom? And so part of this constellation is learning new paradigms for programming and learning new ways that we can make our lives easier. And functional programming is not really new. It's actually been around for a long time. It's been around certainly since the 60s and probably even since the 1950s, right? So that predates certainly me and possibly all the people participating right now in this hangout. So functional programming, the idea came from the world of mathematics, the world of pure functions. And if you think of a function in math, you know, f of x, inside of that f of x, it's not assigning variables. It gets an input, it produces an output. It's not going to, it's going to produce something new based on that input, and that's good. You know, y equals f of x, that we expect y to be different from x. But y equals f of x, after we're done with that, x is unchanged. And so some computer scientists back in the 1950s and 60s said, what if we were to adopt that model for programming? What if we were to, instead of programming with all these imperatives, all these assignments of variables, we were instead to write with functions where we get inputs, it does some sort of transformation, it does outputs, and if we want to do more stuff, well, we just chain more and more functions together. So functional programming is a different way of thinking about programming than many of us are used to. It's not object-oriented, although we'll talk about how we can weave together both functional and object-oriented programming in Python. It's a different way of writing programs, it's a different way of approaching problems, and it often, in my experience, provides us with new and clean and elegant solutions, but you really do need to think a little differently. And so what we're going to do over the next, I don't know, half hour or so, and then open it up to questions, is look at some of these different possibilities in the Python world. And so I want you to think about functional programming really as a set of inputs and outputs with functions. All right, so functions are the key to functional programming, hence the name. And so once again, we hand our input to the function. It does something with that input, but it's not going to change the input. It's going to produce a new output. Yes, BKMT, you are here. Hello. That was probably, now you'll probably see it 15 seconds later, right? So the input goes into the function. The function does something and spits it out, but the input remains unchanged. And so we're certainly not changing any of the state outside of the function. And if we can avoid changing state inside of the function, even better. Oh, the hangout throws. Could someone please hand BKMT the URL so that it'll work for them? Maybe I copied it wrong. I assume you're all able to see what I'm doing. From before, it seemed like you were able to, and there are 9 viewers, so that's good. So why would I want to work this way, right? Because like most of us, when we learn programming, we learn, I can say x equals 1, 2, 3, and x now has the variable 1, 2, 3. Why would I want to throw out the whole idea of assignment when it's so useful? Well, first of all, our functions get simpler, right? We're going to be writing functions. We're going to be writing a lot of functions in our programming lives. And if I can make my functions do less, or I can make them do more, but in less code and with less complex code, then it's easier to maintain and easier to work with. And indeed, the moment that you take assignment out of functions, it's amazing how much easier they are to understand, to test, to debug, and to predict. I mean, every so often, if you've ever had the experience of trying to add testing, oh, you might have to be Google Plus member. Yeah. Oh, sorry about that. Last time people complained that it didn't work on Linux, so I made sure to do something that worked on Linux nowadays. Oh no, excellent. Glad someone else has figured this out. Anyway, if you've ever had the pleasure of trying to add testing to programs that already exist, that's of course not really a pleasure, but it's even worse when the functions are 200 lines long with dozens of assignments. And so the other thing that comes out of this is suddenly our functions become smaller and more composable and changeable. Or ideally, we can sort of build up lots of different functions to do large functionality. So instead of having one big function, I'll have lots of small functions. And then I get something like this, the FB perspective, right? So I have my input, it goes to function 1, goes to function 2, goes to function 3, goes to function 4, goes to function 5. Goes to all these one by one by one until you finally get the output. Now, the trade-off here, of course, is that instead of having one big function that does everything you want, you're now going to have a lot of small functions, and you, as the developer, have to keep track of what these functions are and where they are. And that can be a bit of a sort of taxing thing on our memory. But in my experience, it makes life much easier. It also means that our functions can become more generic, and especially in a dynamically typed language like Python, that's certainly possible. We'll see that in just a moment. Now, this whole perspective is great, but where are the objects, right? Like, Python is object-oriented. We have objects. How does this fit together? And the answer is it fits together very nicely. It fits together very nicely, thank you. Right, so people often think they have to choose between object-oriented or functional styles. And for years, of course, in the programming world, there were almost wars between these people. Objects are great, functions are great, or functional is great, I should say. And object-oriented programming actually arose as a response to functional programming because we had all these functions all over. It was hard to keep track of them. And object-oriented programming said, okay, let's try to put things together. Let's have our data and our methods, functions, methods together in the same package. And then I'll have these nice black boxes. And then I don't have to worry about which function is doing what. And I won't have these sorts of errors as well when I use this wrong sort of parameters. And it turns out object-oriented programming is great. No doubt about it. I really enjoy it very much. I found, though, that this mix of objects and functional programming is extremely powerful. Typically what I do, and I learned this from other people, is I typically structure my programs with objects. I create classes, I create methods, I use them. But within my methods, I'm processing lists and tuples and dictionaries and all sorts of stuff in a very functional kind of way. I'm using comprehensions and I'm passing functions as parameters, on and on. And so the combination of these paradigms, I think, is especially powerful. Now, functional programming, as I said, assumes that we don't want to change the original data. So if I have a function and it gets input, I don't want to change that input. Now, Python supports, of course, there are immutable data structures, right? We have tuples, we have strings, we can't change that. One of the first things when I teach a programming class in Python that people are surprised about is that you cannot change strings. You try to assign to it, but it won't happen. And tuples, the same thing. And yes, that supports, obviously, the functional paradigm. But there's another way it supports the functional paradigm, which is we can just be disciplined not to change things. So you can do functional programming with lists, and you just sort of promise to yourself, I'm not going to change these lists, or I'm not going to change them unless I really have to. Well, given that, then we can do a lot of things in a functional sense, even though Python isn't a functional language per se, but it has a lot of the functional stuff in it. I can then use all the different sequences, which are strings and tuples and lists, and I can use even iterable data structures like dictionaries and files. Anything I can stick inside of a for loop is considered an iterable, and there are lots of things I can stick inside of for loops in Python because of the protocol for iteration, that I can create an object very easily that allows me to iterate over it. We're not really going to have time to talk about that, although if you have questions, we can certainly deal with that later. All right, so the discussion today is mainly about iterables. Let's say I have an iterable, and I want to get to another iterable, or I want to get to some sort of solution. How do I do that? And functional techniques are perfect for that. Well, that sounds like a very limiting kind of factor, right? Like that sounds like a very limiting kind of way to approach programming, but it's not, because so many things are iterable in Python that if I take this input iterable and I deal with it in a functional way and I get some output, well, I've just done functional programming. And the language lends itself to this sort of thinking. We'll talk about this in a moment more, but like you have lists, great. You have tuples, great. You have dictionaries, you have sets, you have files, you read from the network, read from XML, whatever it is. So let's talk about what are iterables again. Like anything I can iterate over, anything I put inside of a for loop. I can even have complex data structures, right? Lists of lists and lists of dicts and dicts of dicts, and of course lists of tuples and dicts of tuples and on and on. Now, where does this come together, right? Where do I take this functional paradigm and this idea of data structures, and how do they get together? Transformation. That's sort of the watchword here, at least the way that I like to think about it. You want to turn one iterable into another. So let's say I have this list here, right? Like I have 0, 1, 2, 3, 4. What I would get basically from doing, that's the same as saying range 5, right? I'm going to get back this list of integers. Well, range 5 in Python 2. By the way, I'm going to be demonstrating stuff in Python 2. So you Python 3 fans, you're right, but you're in a very small minority. Anyway, I can go into detail about my feelings about Python 2 versus Python 3. I happen to think Python 3 is great. Anyway, we'll talk about it more. So let's say I have this list, and I want to somehow transform it into this list, 0, 1, 4, 9, 16. And if you don't see, if it's not obvious to you, the second list is the first list, but each element has been squared. So I want to transform the first one into the second by applying a Python function. Well, what do I really want to do? Let's think about that. And I've started to think about things in this way, that I have this problem, and the solution is sort of beyond the problem. And I have to be able to see beyond the problem to get to that solution. I don't know if that really makes sense to you, but that's how I keep thinking about it. And so I have this list right now, right? I have the 0, 1, 2, 3, 4 list. I want to get to the squares list. So really what I want to do is take each list item, and I want to apply a function like this, def square x, return x times x, and apply that to the new list item. And I can go one by one and do that to each element. Great. And this is the way I would usually expect to do it, right? I'm going to say input equals range 5. Well, that's going to give me my list that we saw before. I'm going to define my function. And then this is the way, fine, I don't have to do this live right now. I think you can all read this code. Output equals a new list. All right, for x in input. So I'm going to take my input, which is range 5. Oh, I probably shouldn't have done that because it overrides the built-in input function. But Python lets you do that, right? I can show you some more magic with that later. For x in input, output append square x. And what do you know? At the end, my output list is there. This is how most Python programmers, in my experience, would attack this problem. They have an input list, they create an output list, they add to it, all is well. And the fact is, this will work. As I increasingly say, the problem is this will work. Now, nothing is wrong. But functional programming people say, wait a second. Why did you create this new variable output? Why do you have to create it? And then you're building it one step at a time. What happens if you have threads and the threads don't synchronize correctly and one thread writes in the wrong way? Why are you modifying the state of output, and why are you doing it so clumsily? Now, people who are not familiar with functional programming techniques hear all these questions and they say, what are you talking about? That's nuts. All I'm doing is taking my list and appending to it. That's a perfectly normal thing to do in Python. There's a reason why lists come with the append method. Yeah, but we can do it an elegant way. We can do it a different way. And again, let's think about what we actually want to do. Let's think about it at a high level. Let's not think about how the computer wants us to do it. Let's think about how we want to do it and see if we can make the computer work in our way. So I want to apply my function square to every element of the input list, and I want to get a list back. So basically what I want to do then is this: input list, transform every element of the input list, and get the output list. And that's where list comprehensions come in. And here I am going to go into IPython for some live coding. Let's do our input list equals range 5. Oops. Actually, my typing is always off when I do these things. I'm going to make the font bigger because last time people complained it was not big enough. So hopefully it'll be big enough now. My first time teaching in China, after you give a course, you typically get some sort of feedback. So I got feedback after the whole course, after the 3 days, that was written down saying the font could have been bigger. This is the sort of thing I could change in real time, folks. So if it's not big enough, if it's not visible, let me know. Okay, so I have my input list right here. Now I'm going to then def square of x, return x times x. Fantastic. Okay, and square 5, it's going to be 25. Good. Make sure that our function works correctly. So here's what I'm going to do. And I'm going to first do it, and then I'm going to describe what I'm doing. Square, let's say n, for n in input. Okay? This is a list comprehension, and I'm going to get back the list that I wanted. Okay, so what's happening here? List comprehensions, I love them. They're super powerful. They're super useful. We're going to go through a whole bunch of them during this webinar, but they are very difficult for people to read when they're new to Python. It's really hard for them. Now, I always make the joke that we're very lucky in Israel, and I guess other countries in the Middle East, that we read from right to left. And thus, it's easier for us to understand list comprehensions. That's a joke, of course, because we don't read right to left. No. The real joke is it's hard to read list comprehensions no matter where you're from. So first of all, you can tell it's a list comprehension. We'll talk about other kinds in a few moments because of the square brackets here. By putting square brackets around this code, that tells Python's parser, this is something special and different. If I try to put this code outside of square brackets, it will not parse. It has no idea what I'm talking about. It sees the word for, thinks I'm talking about a for loop. It expects to see colons, expects to see all sorts of things. And for doesn't return anything. It's not an expression. It's a command, it's a statement. So I must have the square brackets there. Okay, the square brackets say I'm going to get back a list. I'm guaranteed to get back a list. In fact, with this sort of code, I'm guaranteed to get back a list with the same number of elements in the output as are in the elements of input. So if I say len input, we know it's going to be 5, right? I know that there are going to be 5 elements in this output here. Why? Because 5 in the input, 5 in the output. Now, this looks also suspiciously like a for loop, but it's not a for loop. This is the list comprehension. This is where Python says, okay, I'm going to take each element of input. And input is any iterable. So again, it could be a sequence, string, list, tuple. It could be a file, could be a set, could be anything over which we can, it could be a dictionary, anything over which we can iterate in a for loop. And it's going to go over one by one. It looks like a for loop is not a for loop, but we can think about it that way. And for every element in input, it's then going to pass that current element from that iteration to our function. And the output of our function will then be output as the element corresponding to that element of the list. Okay, so basically, I'm going to create a new list. That list is going to have elements. What are the elements of that list? Well, you can think of it as parallel lists, right? I have my input, output, such that the element at index 0 in the origin list will, and the element at index 0 in the output list, they should be the result of transformation there. Well, this is a really powerful idea. I realize it seems like a simple idea, and it is, but it's also a really powerful idea, because it means that I can basically stick any expression there that I want. So I don't need a square function. Any expression. So I can say n times n. Well, I've just done that now, right? I've done the same thing exactly in less code, less overhead. Let's say, here, let's do this. Let's say, words equals, this is a bunch of words. And now I'm going to split that. All right, so words is a list now. All right, let's say I want to join these words together again. Okay, well, I can say space dot join. All right, and now I can say words. Fantastic. All right, because what happened here? Words is a list. I can pass this list, any iterable, to join. Join will then stick a space between each word. Well, what if I want to, stick stars there? Okay, well, it'll stick stars there between, and that's fine too. Everything is working great here until I decide I want to do this to my inputs as well, my list of numbers. And let's say I want to do, a CSV file of some sort. So I want to put commas there. So I do comma join an input, and kaboom, it will not work. And why won't it work? Because, well, it tells us it's expecting a string, but it found an int, meaning that join is going to iterate over our input one by one, take its elements, and do basically a plus to the string. It's going to try to create a new string based on it. But we know that in Python, string plus integer equals kaboom. Can't do that. So really what I need to do is take my input list, right? And this is my input list again. And I want to turn it into a list of strings. Oh, wait, that's a transformation, right? Input list, output list. So let's do that. I can say stir of n for n in input. If I do that, hey, that works great. Now I have a list of strings. And now I can say comma dot join on that. And now I'm not joining a list of integers, I'm joining a list of strings. And now it'll work just fine. This is the power of a list comprehension. This is why I love them so much, because I can do these transformations. I get inputs, I get outputs all the time, and all sorts of things. And it does not matter what the input is or what the output is. As long as you can see it in that paradigm, any function, any transformation will work fine. Let's see, what other, I know I had a few things lined up. Oh yeah, lowercase all words. Let's do that. So let's say I have here words is still there. Great. So I'm going to now say, oh, watch this. Let's make them uppercase. I want all the words in words to now be all capital letters because they're all lowercase. Okay. So I'm going to say word.upper or word in words. Very wordy, right? And here's where we go, right? Now, by the way, newcomers to Python often make this mistake. They forget to put up the parentheses there because parentheses say, I want to execute this method. If I don't put the parentheses here, then I get a list of the upper method. Not exactly what I'd like to do. But let's have some fun with this. Let's say I have, my list equals. Now my list is this list of functions. Well, yeah, but it's these functions that were invoked on a particular word. So I can do this. I can say W, or I can say F, parentheses, for F in my list. Pretty snazzy, right? Because what did I do? I had these methods, and all I had to do was invoke each of them. And how do I invoke a method in Python? I use parentheses. And I think that's just like lovely and beautiful and useful. And the places we can use it, lots of different places. Here, let's do something else. I have, let's see, what direction I'm in. Excellent. So if I say here, import OS, and I'm going to say OS lister of, is it test? I call that? No. ls tester. Okay, so I've got a directory set up here. It has 3 very cleverly named files, A text, B text, and C text. So now I'm going to go for file name in OS lister tester. Okay, so I'm going to get these file names, and I'm going to say print file name. And if we want to be persnickety here, we'll say print file name with parentheses. Great, I have these file names. But what if I'm actually interested in getting back the file object for opening these file names? Well, I can do that, right? I can say, open file name, but then, open file, sorry. I have to say tester /plus. That should work, yeah. I opened it, but what can I do with it? Now I want to do something with it. Once again, we're tying ourselves in knots when we could be doing this much more easily. I can just say open, say, tester /plus file name for file name in OS lister. And now I have a list of open files that are open for reading. I can use these files. I can play with these files. I can iterate over them. I can read from them. I can even say something like this, open tester.read for all these files. And now I get all the content of all those files. Right? And if I want to, I can even say .join on all of these things. And now I'll print this stuff. And now I've printed the concatenation of all of these files together. Right? So I started off with OS lister, which is going to give me a list of file names. I then iterate over those file names, and I turn them into file objects. Well, from a file object, I can read. So I get the string. I now have a list of strings, which we see here, right? This is the output from our list comprehension. It's the list of strings. Well, if it's a string, then a list of strings, then I can join it. So I join it here. Now I've got one big string. I can just print a string, right? And that's what I do. So I get all the files concatenated together. Not too bad for one line of code. I will admit, again, this is hard to read at first. It's hard to keep track of. That's why it's important to me to do a lot of demonstrations, a lot of exercises. Gee, if only there were a book with lots of exercises on such things. Never mind. Anyway, one or two more examples of this. So let's say we want to, let's do this. I want, so you guys might know that the password. Right, that's where we store all the, well, it used to store all the important information. Now it's the usernames in a Unix box, and even on a Macintosh like I'm using. So not really useful for Etsy password. Well, the thing is, no one really wants to read through Etsy password. What we want to do is read lines on Etsy password, and then we get each line in its own element in a list, and then I can iterate over it and grab things. Well, what do I want to grab? I probably want to grab the username, right? That's important. Well, let's think about this. What I have here is a list of strings. Each string is a record. The record is colon separated. So what I really want to do is something like this: line.split of the colon for line in open etc password. Now look at what we're doing here. We're opening etc password, but we're not reading from it. Why? Because a file is an iterable. And because it's an iterable, we can just stick into the list comprehension and we will get its lines one by one. Okay, then what happens to it? Then we're going to do a line split on colon. And now we're going to get a list of lists where each row, each line in the file has been turned into a list here. So list of lists. Okay, maybe, fine. But I only really want the username. Well, the username is index 0, right? Index 0. Now I'm going to go through each line of the file. For each line, I'm going to split it on a colon. That's going to give me a list back. I'm going to grab the item at index 0. And now I have a list of all the users on my system. Not too bad. And I can promise you that, I mean, I don't know what backgrounds you guys have who are on the webinar now, but people who come from C, C++ backgrounds, or people who are coming from like Bash backgrounds and trying to do scripting, for them, this is just mind-boggling. Wow, you know, we can do so much in so little. But wait, that's not all. Hold on a second. Okay, sorry, T calls. There is a problem with what I did here. And the problem is if we go up here, you'll see there are all these comments. How and why did Apple decide to put comments in etc password? I have no idea, but they did. And so this is actually a bit of a problem because I don't want these to be considered usernames in my system. But we said before, or I said before, that that the list comprehension always returns the same number of items in its output as it had in its input. Well, that's not really true. We can add an if statement here. If, and only if the current element passes this if statement, do we get the element with this expression in it. So let's say if not line starts with hash mark. So now I'm saying, and by the way, I've started to break things up like this. I've started to write my list comprehensions like this, especially when I'm teaching courses. I think people find it easier to comprehend. This is my output. This is my input. And this, somewhat confusingly, is my condition. So if the line does not start with a hash mark, then I want to get back the usernames. And now, sure enough, look what I've got here. Just my usernames. I was able to get rid of the others very nicely and very easily. Okay, that's nice. But what if I want to go even further? I would like to get not just the username, but also the user ID number, which I happen to know is actually in ID number 2. So I'm going to now create a tuple, where I'm going to say line split colon 0 and line split colon. That's a little inefficient, I admit, 2. And there's my tuple. And so now I have the tuples of name and ID. Not so bad. Well, if I have a list of tuples, and each tuple has 2 elements, and the first element is hashable, meaning it's immutable, basically, I can say dict for all of this, right? And I can create a dictionary out of it. And now I've created a dictionary of all the users in my system where the usernames are the keys and the user IDs are the values. Not too bad. But enough people were doing this that the Python developers decided to make it easier for us. They made a dictionary comprehension. And the dictionary comprehension basically says, use curly braces just as you would when defining a dictionary. Then say your name, this is the key, colon, value. And sure enough, this creates us a dictionary. I love dictionary comprehensions. I think they're just so incredibly powerful because we're always trying to move things into dictionaries in Python, or I am at least. And this just makes life so easy in so many ways. You can say here, I mean, really, you can put anything in here, right? So I don't need to say the user ID. I can say, the len of line split 0, right? What's the length of the username? Not the length of the username really matters, but any sort of transformation you want to do, you can do. Now, there's another kind of comprehensions that have come in the last few years, which is similar to the dictionary comprehension, and that's the set comprehension. And the set comprehension, as its name might imply, returns a set. It's just like a list comprehension, except that A, the expression here has to return something hashable, and B, it returns a set. Now, why would I want this? Because if I'm searching, let's say I want to find out is root in the list of users? Well, if I use the list comprehension, think of what's happening. Each time I execute this, it has to go and create the list. And then that's not the really big problem. The really big problem is now root in. It's an O of n problem, right? Where it's proportional to the length of the list. And if I have millions of users, then this search is going to take an awfully long time. Whereas if I instead use curly braces, and now I've created a set, true, it takes longer to create the set because it needs to calculate the hash value. You know, it uses a hash function on every element. But once it's calculated, then in just runs super, super fast. It's O of 1, right? It's constant time. Doesn't mean it's always going to be perfectly fast, but it's pretty good. I mean, we love our dictionaries and our sets in Python. So I love set comprehensions. I love dictionary comprehensions. Dictionary comprehensions are great, of course, whenever I have pairs of things, one-to-one mappings. Set comprehensions, truth be told, I use a lot when I want to just throw things at a data structure and know that everything is unique. So if I get a ton of file names, and I don't know, are the file names unique or not, or usernames, or IP addresses or something, I throw it into a set, and the set guarantees it for me. Whether it's stomping on the earlier things or whether it's creating a new one, I really don't know. Okay, let's move on a little bit. Let's see what I can do here. Yeah, fine. Okay, so comprehensions are basically Python's answer to the traditional functions map and filter that you'll find in many, many functional languages. So map is this thing here. It's this mapping, it's this transformation thing, the expression. And filter is this part. And map and filter have been used together for many, many years to help many people work with lots of data. And once you start to think in terms of this mapping, and whether you use map or whether you use list comprehensions or comprehensions in general, which are definitely the more modern way that Python approaches it, you will see this pattern everywhere. You'll be grabbing rows from a database, and you'll say, oh, wait, I want to take the first name and last name and turn them into one string, either in that order or in reverse order, like for a phone book. Well, once you see what you can do with a list comprehension, you can do that really easily. And you're going to reduce the number of assignments you make. You're going to reduce the amount of code you have to write. Your code is going to be shorter and easier to understand. Well, to those in the know, right? There's some who say that comprehensions are terrible because no one understands them. I would argue they're so powerful, it's worth getting everyone to understand them. Of course, I have an interest in that because I teach lots of courses, right? But I really find that these things, these data structures, these comprehensions make life much easier. Let's talk a little bit about functions. And so, like, so far, it's very nice that I've been talking about functional programming now for, what, a little more than half an hour. By the way, I'm going to try to wrap up within the next 10 minutes, at least with my formal part, and then we can do some Q&A. I assume people are still in the chat here. No one's actually asked questions, so I'll just keep barreling along. So where are these functions in functional programming, right? Like, let's write some functions. Let's do something with them. So let's first remember how we deal with functions. And once again, it's important to remember that in Python, parentheses are the way we execute functions, right? So here, let's do this fun thing actually live. So if I say x equals len of ABC, right? So x is going to be, not everyone wants, right? 3. Why 3? Because, well, len is a function. It returned an integer 3. Well, I can do something else, right? I can say x equals len. Well, what's the type of x right now? Type of x right now is going to be int because it received an integer. I can also say x equals len. Notice, no parentheses, no parameter. What is the type of x now? Not everyone wants. Anyway, it is built-in function or method. What? So yeah, I just said that x is alias to the function len. So now len and x point to the same thing exactly. Well, if they point to the same thing exactly, I can probably do this, right? Yeah, right. X and len are aliases for one another. And it might seem weird that we can do this sort of assignment to a function as opposed to assignment to the output of a function. But that's the way that Python deals with it. And moreover, the fact that Python deals with it this way guarantees us that we can pass functions as parameters, and they will be treated like any other parameters. So we're used to passing strings and ints and dictionaries and sets and whatnot as parameters, and all sorts of objects that we've created as parameters to our functions. But we can also pass functions as parameters to our functions. And that's a little weird, perhaps, but it gets incredibly powerful very quickly. Let's take one example. Let's say I have here def a. Let's say return you're in A. Very exciting functions, right? Return you're in B. Okay, well, I can execute A, I can execute B. That's not a surprise. Okay, let's say I want to let the user choose whether to execute A or B. Okay, well, I can do that. I can say, like, user input equals raw input, enter a letter, right? And so I'm going to enter A. Now, user input is the string A. And so I can say, if user input equals A, all right, well, we say A. I say elif user input equals B, B. And then I can say else, print, I don't know what you're talking about. Okay, and sure enough, oh, it returned it but didn't print it. Haha, fine. So let's def A and B again. Print def A. Let's print something. And now I'll go back to my if statements here. And now, here we go, you're in A. And if user input equals B, now it's going to say you're in B. And if user input equals C, it's going to say, I don't know what you're talking about. I get that a lot from people. Okay. Well, that's fine, sort of, but it seems really clumsy. And if you have 2 functions, it's already clumsy. Imagine if you have 10 functions or 15 functions that you want to possibly do. So there has to be a better way. Now, in some languages, you have switched case statements, and you could use that. But that's still kind of ugly. It's not exactly the way we'd want to do it. It doesn't feel like the Python sort of way. And besides, Python doesn't have a switch case statement. Actually, I sometimes tell my students it does. And switch case in Python is spelled IF. Well, what's another way to do that? I can do something like this. All right, I can say menu equals dictionary, A, B, B. Well, wait a second. What are the keys here? The keys are strings, right? Menu.keys. Return a list of strings. What are the values? The values are our functions. That's right. The values of my dictionary here are functions. And so if I say menu of A, I get back a function. Well, how am I going to execute a function? Parentheses, of course. Menu A, parentheses. Menu B, parentheses. This is known as a dispatch table in the computer science world. The dispatch table is a dictionary that we can use where we look up a name and we get a function back, and that tells us what function we want to execute. Okay, so now we can say user input equals raw input, enter a letter. I'm going to say A. And now we know that user input is A. Well, now I'm just going to say menu of user input, parentheses, and voila. This is how we can do a dynamic dispatch, or one way we can do dynamic dispatch table in Python. And it's so easy, right? I just define my dictionary. No, not that one. Oh, menu. This is my dictionary, right? It's keys and it's values, but the values have to be functions. Of course, I don't want to do this, right? That's not a good thing to do. Because now what is my menu going to be? None and none. Why none? Because each of these functions had a print there, did not have a return. So big, big difference between parens and no parens, folks. Don't forget. Okay. What else can we do? Dispatch table is good. Sorting. Oh, yeah, another good example. I think after sorting, I'll sort of summarize, and then we can do Q&A. So let's go back to our words, right? This is a bunch of words split. So let's say now I want to say word sort. Let's say I want to sort these things. All right, well, it's going to sort them. Fine. But let's say I don't want to sort them in this way, right? How did it sort it? By the way, it's sorted in ASCII order, increasing ASCII order. And of course, I can reverse that, right? I can say words sort, reverse equals true. But there are basically 2 problems with what I've done here. One is that I've modified the list. And I said before, it's true that we can modify lists in Python, but we usually don't want to. Excuse me. And so what we can do is say sorted instead. Sorted is a built-in function that does not modify the inputs, but it does return the sorted output. Okay, so it's still sorting it by ASCII, but I didn't tell it I wanted to sort it by ASCII. I actually wanted to sort it by length. Oh, well, now I'm sort of in trouble, right? Well, not exactly. I can tell Python key equals len. Look what I'm doing here. I'm passing len. I'm passing the function as the parameter, or to the parameter, key in sorted. Sorted then will get this function and apply it. It'll use parentheses on every single item before it is compared with something else. So it'll be sorting a bunch is, but it'll be sorting on the length of a, the length of bunch, the length of is. And sure enough, now we get them in increasing order there, increasing size order. And of course, if I want to say, oops, reverse equals true, true, that'll work also. Now, the advantage of using sorted is not only that it doesn't change our original list at all, but also that I can do it on a tuple, right? Words equals tuple of words. Now, I really cannot sort them, right? Word sort is just not going to work, right? Because tuples cannot be sorted. But I can say sorted of that, and that'll work just fine. Notice that sorted returns a list. And so we can pass a function. We can pass any function we want to sorted as key, and it'll do whatever we want there. I mean, I can reverse things, right? I can say, watch this. We have a lot of time here to talk about Lambda. I'll talk about Lambda super, super fast. Lambda is a built-in in Python that returns an anonymous function. Okay, so I can say lambda x times x, right? And look, there went our function. But I can say z equals lambda x, and now I can say z of 5 is 25. Okay, fine. I can use lambda anywhere I can use a function. And sometimes if I want to just have like a throwaway function, that's what I'll do. So instead of saying, I want to do, I want to sort these words, not by length now, but by the reverse alphabetical order. So really what key needs to do is be a function that reverses each word. Well, what I need to do then is say key equals lambda, w, let's say, for word, w, and let's use the : -1 hack for reversing reverse slices. And now let's see, oh, reverse equals true. Let's remove one level of reversing in our lives here. So that's A, F, H, S, S, and S, right? It's sorting in the order according to the lambda that we've defined here. Okay, so that's always a lot of fun. The thing is, you can do this too. You can write a function that takes a function as a parameter and then applies it. And now you have a more generic function whose behavior can be modified. And this will be my last example. I use not only a lot of Python, but a lot of Ruby, especially Ruby on Rails for web stuff. And the latest version of Ruby on Rails, they had this thing called transform values. Transform values is sort of like maps, sort of like a list comprehension, but for the values of a dictionary. So let's say I have my dictionary here. I would say transform values of lambda x times x on D. So this is my function, and I want to apply it to the values of D. So the keys stay the same. So A of 1, that stays the same. B of 4, right, because that's 2 times 2. And C of 3, that becomes C of 9. So how could I implement that sort of transform values? Well, let's see. Def transform values. And what I'm going to take, I'm going to take a function. I'm going to take a dictionary. Okay. And now what? Well, I want to go through the dictionary's keys. And for each key, I want to return that key. And then I want to return the result of invoking the function on the value. So really what I want to do is something like this. F. So I want to return like D and F of D, well, like key, for key in D. Something like that, right? Well, that looks kind of familiar. That looks like a dictionary comprehension, right? And now I've implemented transform value just without the S. So now if I say D equals A1, B of 2, C of 3, and now I'm going to say transform values, and I'm going to pass it lambda x, let's say stir of x. Oh, I could just say stir. All right, that's good enough. Stir, and my dictionary. What happened here? What did I do? What did I do? Oh, duh. Someone need to correct me. I don't want to return D. I want to return key. There we go. Return the key and the value, not the dictionary and the value. Thank you all for paying attention. Thank you, thank you. Anyway, so I'm going to transform values. Here we go. And now, oh, I forgot to return that. Not my day, is it? That's why consultants charge by the hour, folks. All right, and now I do transform values. So here we go. So what happened? I invoked transform values stir D. That means this is the function I want to apply on every value of D and keep the keys. Return, dictionary comprehension, key, and the result of invoking my function D key. But I can pass another one, right? I can say float, and now they're all turned to floats. I've now created a function that is so much more powerful than it would have been if it just did one thing. And that's really the message I want to give you tonight, which is the combination of these techniques can provide us with incredible power and flexibility in our programming. The comprehensions are modern versions of map and filter. We don't even have time to talk about reduce, although if people want to ask about that, I'm happy to go on and on about reduce as long as you want. This becomes easier with practice. It takes time to sort of understand how to think about things from this perspective. But when you do, I'm telling you right now, people come to me sometimes with problems when I'm teaching. They say, oh, we really want to do X and Y and Z. And sometimes they're hard problems, right? Sometimes there's just nothing to be done. But sometimes there's a trivially easy answer from the functional world. So I want to open it up to questions. I appreciate your patience and your relative silence, I guess. I'm used to people in Israel, always yelling and arguing and challenging me on everything. So first of all, I want to let you know, if anyone is interested in practicing lots of things, my book is available. You are welcome to buy it. I have a 100% money back guarantee. So if you feel that I ripped you off, it's currently still not quite ready. I promised people there are 50 exercises in the book. They're now about 40, I think. And some of them need a little rewriting and fixing. So it's in pre-release right now, but I've started advertising and telling people, if you want, you can get 10% off. Just use the webinar code, right? So when you go to here and you click on the I want to buy this book because the greatest thing ever written in the world. Okay, it doesn't really say that, but it could. When you click on that link, then it'll ask you what coupon code you have. You enter webinar, you'll get 10% off. And then you'll be welcome to have the what's it called? The book. And obviously, I'll be updating a lot in the next week or two. Hopefully, really within the next 2 weeks, I will have the whole thing done. And then I'll also be doing some packages, including video explanations, sort of like I did here tonight, that every single exercise of the 50 not only will have a printed answer, but a video answer. In some cases, probably even 15, 20 minutes long, describing what's going on. I offer courses online as well as in person. I would very much enjoy hearing from people who want to take those. I was going to do courses next week online, but I actually just got a call today from a client who really, really, really wants me to come in and help them to save their database next week. So I don't think I'm going to be doing the courses next week. I'm sorry. I would be delighted to hear from you folks on consulting work or just generally questions. And you can contact me. You can follow me on Twitter. Be happy to hear from you. So I guess at this point, if people have questions, I would be delighted to answer them. If they don't, you can all go to bed. So any questions, comments, personal problems? I guess I should write in the chat as well. Okay, well, if there are no questions, then I've clearly bored you folks all to death. No, I know it's late for me. Might be late for you guys as well. Or maybe I just answered all your questions. I'll give it another few minutes, and if no one has questions, then we'll call it a night. This was recorded because it's done on Google Hangouts, and so the recording will be on YouTube, and I will send the email both with a reminder about the coupon code and what I want to say, and also with the URL of the thing, URL of the video, so you can all watch it again and again. Yeah, look. Need to absorb the info. I really understand. Look, I so clearly remember at the age of 18, which was a long time ago now, age of 18, arriving at MIT, and someone saying, "Oh, it's Unix. Why you don't know Unix? Oh, it's so easy," and starting to just babble at me all these commands, which nowadays I take for granted and use every day. But it was just this like incredible torrent of information that was hard to absorb and hard to understand. And a lot of the things I talked about today, even though we sort of only scratched the surface of them, it's a lot of stuff to take in. And even when you sort of understand it, it's then hard to use and create with it as well. But hopefully all of you will be able to use it in your work and fun and studies and whatnot. Oh, the slides. Yeah, how much does that work for you? Yeah, I will figure out a way. You know what I'll do? I'll see if from Eventbrite. You know what? Here's the thing. I think I will just tell people in Eventbrite, like in the email I send out, send me email. I can tell you that now too, right? Like send me email and I will send you the slides. I do a lot of training through this company in Israel called John Bryce. And just, I guess, about 2 months ago, I was giving a course in Tel Aviv. And I always email the slides from whatever I do to the participants. I mean, like the commercial courses, I don't put them online in SlideShare. I guess I could do SlideShare, actually. I hadn't thought of that. But I tend not to do that with the commercial courses because, you know, making some money from them, don't want them passed around too much. And I said in front of the people running the course, I said to the people from John Bryce, in front of the people from John Bryce, oh, you guys can just email me and I'll send you the slides. And they freaked out. They're like, no, we don't have the rights. And what will happen? And I said, no, I wrote. Feel free to be in touch if you have more questions. And I will, as I said, probably be doing more of these, almost certainly be doing more of these. So look for information about a month from now. Look at my blog. I write increasingly a lot on my blog, you know, in case it's not obvious, right? Like that's my blog. Feel free to look there. Oh, wow, that's cool. Where it brings up like a thing. Anyway, thanks so much for joining me. I appreciate it, and hope to talk to all of you soon. I'm going to turn this off now somehow. Clunk. Bye.